Within minutes of gaining their 2300 MHz license from Ofcom, at 1 PM on the 12th of April this year, O2 launched their commercial 2300 MHz 4G network on 60 sites across London. And since then it has spread to additional sites. Roughly 100 are equipped so far, spread out across London as well as a few outside the M25 in like Slough, and then also a few sites in Leeds as well now. And in this video I'm going to talk about the deployment that they have, including talking about what the masts look like and what the equipment they use is. So first off, let's talk about the 2300 MHz spectrum that O2 operates this commercial 4G network on. They were awarded 40 MHz of spectrum during the auction process, which exists between 2350 and 2390 MHz as a single block. And with this they can operate two 20 MHz TDD carriers, with one operating using the EAR FCN of 39250 and the other 39448. The former uses the cell ID pattern of 1x6, so say 116, 126, 136, and the second carrier uses the pattern 1x7, so 117, 127 and so on, although we've only really seen the first carrier deployed publicly in London, for example, so far. Device support for this band is quite good, with most modern flagship and even mid-end devices supporting it, so iPhone SE and above, and then the various OnePlus phones, as well as devices like the Sony XZ and XZ Premium. Now this list is not exhaustive by any means. There are actually tons of devices that support it, and some of the ones I've listed there do have some regional variations that might affect their ability to support band 40. Configuration wise, the 2300 MHz is operated in TDD config 2 with special subframe 5. As could be seen from the screenshots on the last slide, as the screenshots on the last slide showed, there was 44R on the mast side and 256 ground modulation. So if we put this together on both the carriers, the maximum throughput available is very high, over 500 megabits per second in fact. However, device support for 4x4 and carrier aggregation on 2300 MHz is not particularly so good in devices that have been tested so far, and therefore these theoretical speeds will be well out of reach for many. And of course they're only achievable in optimum signal conditions anyway, which is quite hard to come by with obviously the amount of users and load which will be on these sites due to their central locations. O2 used two vendors for their radio access network equipment for 2300 MHz, Nokia and Ericsson, which replicates the vendors they use for their frequency division duplex broadcasts in the respective zones as well. So areas that are Nokia for 800, 900, etc. are Nokia for the 2300, and areas that are Ericsson for 800, 900, 2100 and so on are Ericsson for the 2300. Now that we've seen the two different vendors that are used, I will start off by talking about the Nokia deployments. These use FZNJ remote radio units, which are 44R and have a frequency range which is dead on what O2's block of 2300 MHz spectrum is, so 2350 to 2390 MHz. They have 40 MHz of instantaneous bandwidth, which is obviously ideal considering there's 40 MHz of bandwidth here. And these are used in the O2 Nokia region, so London, the southeast, and some of the Midlands of the UK. The Nokia site upgrades to this commercial 2300 MHz come in two different types. So the sites that were pre-commercial trials of 2300 MHz were built as 8T8R using Huawei remote radios. and these are being swapped out to 44R on the Nokia FZNJs. So the extra feeders get decommissioned, and the new Nokia equipment gets put in using 4 out of the 8 ports on the Huawei ATD 4516 R5 antennas. Meanwhile, sites that were built up for 6-sector operation that use the CommScope antennas have spare ultra-wideband ports on the back of the panels, in fact 4 ports, which can then be used to operate 44R2300 alongside the rest of the technologies in that panel. These sites also have a dual beam low band panel, which then broadcasts the 2 beams for 6-sector operation of 800 and 3G 900. The Ericsson 2300 MHz currently only exists on a couple of sites in Leeds, and these use Ericsson's radio system, or ERS, remote radio units. Typically O2 Ericsson sites only have a remote radio unit for 800, which is the RRUs 11 in this picture, so I was a bit surprised to see other remote radio units alongside the one for the 44R2300, which is just below the Catherine dual band antenna. The panel on the right has also been clearly replaced, because on this site before there was a fairly standard Catherine antenna like the 800 10698, and that's been replaced with a CommScope antenna, which I would suggest is a quad band Argus, and that will be used because usually on sites like this there would be a triple band Catherine antenna at the 800 10698, which will carry the 4G 800, the 4G 1800 and the 2G 3G 900, with the 3G 2100 then going through 2 of the ports on the Catherine dual band antenna. However, as the Catherine dual band now has just 2300 MHz going through it for 44R, you then have 2100 MHz which needs to be connected up to something, and while they could have diaplexed that with the 1800 on the Catherine 800 10698 or similar, they have clearly decided to stick a quad band antenna up instead, which does give them independent tilt control on 1800 and 2100 MHz as a clear benefit. The schematic shown is a little bit of a best guess for some of the FDD frequencies, because we know that one of the remote radios is being used for the 44R2300. That's fairly obvious due to the feeders connecting it to the Catherine antenna, but that leaves 3 other remote radio units. One of them, the RRUs 11, will be being used for 800 MHz, so that's fairly straightforward, but then we get 2 other remote radio units and 3 possible bands. So 900, 1800 and 2100 are all FDD frequencies, and we've only got these 2 remote radio units. Because of the future possibilities with 2100 MHz on this site, so refarming it to 4G, and the overall bandwidth potentially required to allow their MORAN partner to also refarm, I thought that fitting a new remote radio unit for that band would have been a wise move, and that's why I put 2100 on remote radio. So that then leaves 900 and 1800 MHz to decide which one's remote radio and which one's passive. 1800 MHz is only 5 MHz bandwidth, so the conventional RUS radio units can very easily deal with that, even if both operators want to do it in MORAN. For 900 MHz, however, the bandwidth that O2 and their MORAN partners, so Vodafone, have is both over 17 MHz, which is potentially quite a lot for the standard radio units that O2 would have deployed, and therefore again sticking a new remote radio unit with increased capacity in the form of instantaneous bandwidth for that frequency, I thought made sense, and that's why I've put 900 on remote radio and 1800 as passively fed from the radio units in the base station. Thanks for watching this video about O2's 2300 MHz 4G. As it is currently deployed on about 100 sites, it's hard to know what the deployment will look like as it spreads much more widely, because these are still quite early stage installations. So as time goes on, I will no doubt produce another video about this, showing what the deployment looks like then and how it's changed, if it has changed, and with any updates or perhaps, hopefully not, corrections to what I've said in this video, specifically the Ericsson setup, because like I say, I don't have the full details of what all the remote radios there are doing. So I've kind of tried to use a bit of logical thinking to try and work out which of the frequency division duplex remote radios are doing what. So check back and I'll see you on the next video.